When the bell rings, you see in your seat. So close. Diego, good. Yeah, pull that chair over. Perfect. All right. I should see you working on this. Do first. Quick thing to point out though. A and D. When I made this multiple choice problem, I started and just pasted a bunch of them and then changed a bunch. And D and A, notice they're the same. So I'm going to change D to 5x cubed. Did y'all hear that? D is the same as A, change to 5x cubed. Think about vertical and horizontal asymptotes. This would be a non-calculator question that you should be able to figure out with your asymptote rules. I'm going to have you work on this independently and silently. Independently and silently, please. Think about your rules for vertical to help you find the denominator. Then think about your rules for horizontal to eliminate any other answer choices. Israel.
Here.
Felix.
Here.
Edith.
Here.
Eli.
Here.
Dahlia.
Here.
Stephanie. Diego.
Here.
Jimmy Lynn. Sandy.
Here.
Brandon.
Here.
Brian.
Here.
Juan Carlos.
Here.
Martin.
Here.
Nen. Kennedy.
Here.
Giselle. Leo. Gustavo. Lirio.
Here.
Tyler.
Here.
Melanie. Lazaro.
Here.
Jonathan. Messiah.
Here.
Joanna. Kevin.
Here.
Dehong. Christina. Johnny.
Here.
Luis.
Here.
Deanthea. Brian.
Here. Oh.
Even if you're done, if you keep your voice off, I'll keep it short. Okay, let's go ahead and get started. Alright, so taking a look, I'm going to try to keep rolling in some multiple choice or some more assessment questions to practice the things we've done before. So last week we focused on asymptotes, horizontal, vertical, and then on Friday we added in slant, asymptotes, and holes. So all those rules are floating around in our head and need to be starting to stick so that we have them memorized. So taking a look at this, I see two vertical asymptotes, these dotted lines right here, which should give us information about our equations. So let's start with vertical asymptotes. Raise your hand if you can tell me which answer choices you kept because of the vertical asymptotes that you saw and why. Lirio, go for it.
A, C, and D, because because for the next one, it was like -2 connected to a positive in the equation, and then the right one is positive, it would have to be in the equation.
Cool. So we knew we could eliminate B, she said, because in order for it to be a -2, we would have to say -2 plus 2 to give us 0 on the bottom, right? So vertical asymptotes are where 0 on the bottom. Okay, now we've got 3 left that have different powers of x on the top, right? One is x to the first, one's x squared, one's x cubed. So we're definitely talking about powers, like exponents, which means now we need to look at our horizontal and figure out bigger on bottom, bigger on top, exponents are the same, which one do we want for our picture here, okay? So taking a look, thoughts from the crowd, I'll let y'all kind of help me out. Iham, did you have an idea? The letter?
Has to be bigger on top.
Okay, let's talk about that. So which one did you say? Okay, because you don't see any horizontal asymptotes? Okay, that's good. Any other thoughts? Kennedy?
Would it not automatically be D anyway because cube makes it?
Cubed, like I agree, a cubic function looks like this, but it doesn't mean that when we graph something else, like in a rational situation like this is not a normal transformation of x cubed. Like these are just different equations that can look all sorts of crazy stuff going on. So if it's part of it, could still look cubic, whether it's cubed or not.
Doesn't the square make it even instead of an odd shape?
So again, that's with a polynomial. So we're not talking about a rational function with the top and the bottom. All those rules are only for when it's like 3x squared plus 2x plus 5 and things like that. Okay? Brian, when you graphed it, which one did it look like, or which one did you end up saying? Because I saw you graphed it on your calculator. A. A is the correct answer. So let's talk about why there actually is an asymptote and where it is. Okay? So let's talk about this. But that's kind of tricky between, so I wanted to kind of see. I would start with your vertical asymptotes like y'all did, and then the horizontal is just a little tougher. So let's talk about it. So in general, the bottom of all of these are factored, right? But if you were to put it back into standard form, what would be your leading term if you multiply this out? What would we have on the bottom? X squared, blah, 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 right? Okay, so let's picture that. If all these is x squared, something, 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 this is where Iham said this is bigger on top, so that would be none, right? That looks none to be dragon. Okay, this one would be exponents are the same, so we would divide the coefficients, and that would be 5 divided by 1, so y equals 5. Up here at 1, 2, 3, 4, 5, I definitely don't see my graph like leveling off, right? Because an asymptote is somewhere where our graph seems to be approaching that value, and this is going straight through it on either side, right? Okay, let's try this one. If it's bigger on bottom, squared on the bottom, what is it? Y equals 0. And notice here, I know we've got this middle part of the graph, but the ends of our graph are leveling off right here at 0. So in the future, like I'll try to make it a little more obvious when it's approaching or leveling off. But anytime you see a graph that's doing something like this, that isn't going straight up or straight down and seems like it's approaching something, means you are going to have some sort of horizontal asymptote. And in this case, our horizontal asymptote is at 0. Okay? Which is why our equation would be a tough one though. Okay? But if you at least could identify your vertical, then yay you. Okay, so today, a few things coming up. Do you need anyone? I'm just gonna go for it. Today we're gonna do a quick kind of like mini lesson on something I feel like we kind of brushed over and didn't get to talk about as much. So we're gonna continue to talk about this graph in a second and talk about limits, not just for end behavior, but for asymptotes and parts in the middle of our graph, okay? It's gonna be like a quick 5 minutes to knock that out. And then the rest of class is gonna be talking about one of our last topics of the unit, which is gonna be solving rational equations, okay? So announcements about what's coming up. I should have gotten today's problem set, and if not, I need it by the end of the day in my inbox, okay? Can you all grab Leo? I think I missed because he was in the restroom. Can you all grab his and pass that over? Perfect. You just got from the blue folder problem set 4, which is due next Monday. So this is your last big practice for the assessments that are coming up in Unit 2. So even though it's due next Monday, I encourage you, as always, to start early so that you're getting this practice ahead of time. Because Wednesday, after tomorrow, we will have learned everything in the unit. So Wednesday is your second quiz of this unit, and it's the pre-unit test. So it's basically like a mini version of the unit exam where you're going to be able to see where you're at for this unit, okay? Thursday, we're going to review anything we struggled with on Wednesday, okay? And then Friday is our unit exam. So we got a big week of assessments coming up. Today and tomorrow are the last days of lessons, and then we're going to be assessing for a lot of the last part of the week. Yep. Tomorrow. So we'll be learning something still new tomorrow. Okay? So I will be here today after school, tomorrow after school, Thursday after school, if you need help, but then get started on the problem set. Big part of the last part of the problem set is all review, a lot of multiple choice problems, but I need you showing your work, and then the first page is going to be kind of what we're doing today and tomorrow. Okay? Alrighty. That's all I got for announcements. So let's go ahead, and before we jump into solving rational equations, like I said, we're going to do a quick little explanation on limits. So we're looking at the same graph. Y'all see the graph at the top. We're looking at these limits kind of midway down your page. We have talked about a lot these kind of limits. Limits as x goes to infinity or x goes to negative infinity. Do those look familiar? Yeah. Those are our ends, right? Our end behavior. This one right here, x going to negative infinity, which side of my graph is that talking about? That side over there as x goes to negative infinity, the left, right? So our answer, remember, is the y value that our graph is approaching. So over here on the left, this pink part right here is going to keep on going, and we're trying to describe what it's approaching. Is it going up forever? Does it look like it's going straight up forever? Down forever? It's like leveling off, right? At our asymptote, which we said is at 0. So it's leveling off. It's not going up like this one to infinity or down to negative infinity. It's flattening out at 0. Okay, from the, on the right, that's this piece. Up forever, down forever, or flattening off? Yeah, whatever, I don't know. We're just describing it. And where is it headed? Same thing, 0 on that side, okay? So we've done end behavior before. I just wanted to make sure you can write it from a graph that looks like this. Now let's talk about what happens if your limit is not going to infinity. What happens if it's headed towards a number, so somewhere in the middle of your graph, okay? If that's the case, a lot of times you're going to see this little plus or minus, and we haven't seen this much, so I want to kind of like recap. Whenever we see that on a limit, this obviously does not mean positive 2 because it's already negative 2. This little plus tells us which side we're approaching when we're trying to describe the behavior. On what side of negative 2 are we looking at? Yeah, the positive is which side? The right. Makes sense because positive numbers are on the right, right? And the minus is going to be coming from the left side of that number, okay? So let's kind of translate this. This means the limit as x approaches negative 2, let's find negative 2, here it is. Write this asymptote. As x approaches negative 2 from the, if it has a little plus sign, from the right. So we're looking literally just to the right side of that negative 2, and we see this portion of the graph right here, just to the right of negative 2, right? Where is that portion of the graph seem to be headed? Up, up, up to negative infinity. So again, you're just describing that behavior, but now not at the end of the graph, we're describing it on the right side of negative 2, what's happening, and it's going to infinity. Okay? Take a second then, independently right now, and then I'll quick check it, but I want you to write what you would think first. What would you say is happening, not on the right side, but now on the left side of negative 2? What's your graph doing right on the left side of negative 2? Write down what you think, and then let's check it. 10 seconds to write your own answer, guess. See if you got it. Any brave souls out there? Eli? Okay, let's take a look. You're looking over here, and he says it's approaching 0. Okay, other thoughts? I have a 0, a vote for 0. Stephanie? What were you looking at? This part? Okay, which one seems to be, as the graph is approaching -2 from the left? Which one's close to -2 but just on the left? Stephanie's or Eli's? Stephanie? Eli. Stephanie? Eli. Which one's closer to -2 on the left? Stephanie's, right? So you're close. What you're describing is as x goes out to -infinity, right? We're talking about as x gets really, really close to -2 on the left side, but it's not quite there. Where is it? It's headed down to -infinity. Good try. Cool? I learned that if y'all try to answer it first, even if you make a mistake, it sticks more next time. So Eli's gonna get it next time.
Yeah.
That's what happens. Apparently, like if you you're like more invested when you like saw your wrong answer and then you see your new answer. Yep.
How do you know which graph to
Of these 3 pieces. So I'm looking for the graph that is just to the left of -2. Is this just to the left of -2?
What's the thing in the middle of the chapter?
This thing is, we were looking at it when it was right of -2, because isn't this to the right of -2? But if we're looking to the left of -2, like this piece of the graph is not over there. So that is not describing the behavior of the graph left of -2 if that part of the graph is not over on the left of -2. Okay? So we're basically, the limit describes a location on your graph, and then we're describing in our answer what the graph's doing in that spot. Okay? So let's talk now about 3. Let's do another 10 seconds. I want you to try to write your answer. We're approaching 3, so you should be looking over here on your graph. First one on which side?
Right.
So look just to the right of your asymptote and see where you think your graph is headed just to the right. And brave soul from the crowd. And we gotta give Eli and some people their stamps. Brave soul? Any brave souls? Oh, I see a lot of brave souls. I like it. Kevin?
I guess.
Why are you guessing? Y'all need to be confident because you're right. No. You're right.
Alright,
Hey, that's me. Hold on.
If you wouldn't have said you're guessing, then we would have been like, man, Kevin's got this. But when you say it was a guess, then we're like, you're good. Okay, so right here, if we look just to the right, so again, like I agree, Kennedy, there's 3 pieces of our graph, but just to the right is this piece of our graph, right? And it's headed up to -infinity, right next to 3, but not quite there. Okay? Alright, and last one, 3 from the left. This does not mean jump to -3. This still means +3, but the negative means from the left side. So if we look just to the left, just barely to the left, where is our graph, Sandy? -infinity, and ends up being the same as these answers, but that's just a coincidence. Okay? So limits from the left, limits from the right. Happy? Okay, I'll come give you your stamp, Sadie. Alright, now we're moving on. But I'm actually not going to teach much. I'm going to let you take the reins first. I want to see what y'all can come up with when you see something that looks like what? What happens when you see something that looks like this, where you have what we call a rational equation because you got numerators and denominators. Basically, you have fraction-looking things in an equation. I want you to talk to your neighbors before I talk through this. I want you to see what y'all can come up with for these 2 problems. Go! Be focused. You can do it, Giselle. No sleeping. Giselle's like, go. Not allowed. What would you do with that? How in the world did I have those things together? Not yet. You gotta do one of these first. Okay, so cross multiplying is like when you have something that looks like this.
How do you know?
Okay, you can cross across the equals. Which means like if you had one of those things equal to 5 or something, you could cross multiply, but you can't do it like across the plus sign. Does that make sense? What happens, how do we add fractions? So you can do it once you get these two things together, but you need to add those two things. And you need a common denominator. And it looks like she's trying to make them into 20s. Common denominator. ¿Esto se llama? Yes. He's trying to make it into 20. I love it. Let me say. Lovely. Can you try the next one? Keep on going.
That's fine.
Yeah. What are y'all talking about? Denominator, right? If it's 4 and a 5, what are you trying to get? 20. So let's think about the first one. If I wanted a 20 on the bottom, right now it's a 4, I would have to multiply times 5 on the top of the bottom. So you could rewrite this as 15 x 5. 15 x. Yeah. And then the next one you would have to multiply times another L, 4. And I would even put it on the other side. So think of it as 7 over 1. What would you have to multiply by to get 20 on the bottom? 20. Yeah, finish that one first. That's how so we're going to
I don't make chicken like that.
You gonna learn how to. I don't know what I did.
Just one, boy. Just one. Just one.
Seven over 1. You can think about it as 7 over 1. So you multiply by 20 on the top of it. And then if you have that, you can basically take Okay, give me about 10 more seconds. Let's try. Eventually, but in order to get that answer, you're going to need a common denominator. And so Huh? Can I see what your Okay, then go and then we'll talk about Oh no!
Oh, that's what
Is your chatting with them? Is your chatting? Can you try to come over here? And then let's make one for 7 too. 7 over 1. You can just put the 20 on the 20 on. Oh my god, okay, yeah. 20 on the bottom.
What she
You can't cross multiply when there's condition. Cross multiply when it's like.
India. What did you divide? What'd you do?
Something like you would like.
Oh, what I did?
Yeah.
Okay. So I did like.
Okay, let's see where we got to start off with.
Right here.
And we're going to use that to kind of like launch into how to solve a rational equation. So, when you see something like this, like fraction type looking things, what do we need to find to be able to start combining and moving and doing anything with our function? Does that? You need to find a common denominator. In this case, what did you use, Giselle?
I used 20.
20. So, I agree, that's like, that everyone had in common. Then some people went kind of some different routes, so kind of stick with me. Doesn't mean that if you didn't do exactly what I did, yours wasn't necessarily correct. But, we're going to rewrite all these as 20ths. So I saw a lot of people that had, for the first one, 15x over 20 and 8 over 20 when they changed those two. Then, not everyone changed the 7, but I saw a lot of people that did, because they just wanted 20ths, 20ths, 20ths across the whole problem. If they did, they had 140 over 20, because they multiplied times 20 on the top and bottom. Okay? Alright. And then again, I had a lot of different things. Some people subtracting the 8 20ths over, and then doing different things. The cool thing about finding a common denominator in an equation is that once we get everything with the same denominator, I could essentially multiply times my common denominator on both sides. As long as I multiply times both sides, it's still the same thing, it's balanced, right? And if I'm dividing everything by 20 and now I'm multiplying by 20, what does dividing by 20 and multiplying by 20 do? They like cancel each other out. So basically all of these 20s boom, 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 are going to be canceled out, and I end up with just my numerators. 15x plus 8 equals 140. So a lot of times you're going to see me today, when we get to this point where they're all common denominators, I'm going to say that we're multiplying both sides by 20, but you're going to see me just like, it's a efficient strategy to now just say like, oh, they're all 20ths, so I can just set all my numerators equal like that and solve, okay? So now subtract 8, then divide by 15. I'm not going to do all of that by hand right now, but those of you that got there, you can check your answer. 8.8 is what we end up getting here. Yep. If this was like 7 over 1, and if I want to make it 7 over 1 into 20ths, I multiply times 20 on the top and the bottom, and I get 140 over 20 if I multiply 7 times 20 on the top. Okay. Y'all try then. I'm going to give you, let's do 2 more quick minutes, because I want to keep this moving. 2 more quick minutes to try the next one if you haven't already. If you have, I'll come over and check it. 2 minutes, try it out. Here. This minus is in front of both of these things. You're subtracting 4 and you're subtracting negative 2, so there should be a little plus 2 right
You won't.
It should be okay, I think what happened here is when you have this plus 5, this right here is a minus 2x and a minus negative 1. Which meant you would have had to plus 1. Okay, this is good. When you have a minus 4, you also have a minus a negative 2. So this should become a plus 2. But you're subtracting both of the things. So you actually have to distribute the negative. So this would be a plus 2, which makes it a...
Is this right?
I know, what happened there? Ah, here. This is this one. It's actually not yours. You would multiply 6 times 2. Okay.
These are
Oh, no.
that's X.
It's a negative.
Minus this is X. This is already
I didn't know how to put it over here, but you can do that. I use 6.
I mean, 6
Which either should work though, but I'm just trying to find out where your mistake is. So you have 6x
is minus.
plus 12. Hold on, sometimes when I look at y'all's work, I get confused. Minus 4x plus 2
Oh, it's 5.
Here we go. 6, 5 would be 2. 2x. 12 plus 2 is 14.
I put in this equation.
Minus 14.
1 and then I found
It's a 7. Yep. Woo! Good job. All right. Yes, we go. Okay, bring it back. Bring.
This is my calculator.
Okay, bringing it back. 3, 2, 1. Voices off. Okay, Juan Carlos, what did you use as your common denominator? We're not going to go through the whole thing, but 6. Perfect. I use 6 as well. I did see some people. What did you use? 12. It works. It's not the least common denominator, but it's common denominator that you could use. Regardless of what you use, I can come one off with you if you got something else and check it. But we're going to move on. You should have gotten -5 for that one. Okay, I'm going to bring you to some stamps. Alright, voices off. Eyes up here. I can one off with you if you got something else. Okay, so here's an example of like kind of a little more basic skills for your sponsee, where you could have one equation carried through parts like A and B to give you an idea of something that you could see that ties in what we're doing today with kind of what we're doing last week. So take a look at this problem. Can I get someone to read A for me? You don't have to read the whole function. You can just say f of x when you're reading that part. Yep, go for it, Johnny.
For the function f of x, sketch a complete graph including all asymptotes and removal continuities if they exist.
Okay, so we're going to start, we might not sketch the entire graph, but we're going to identify all of the asymptotes and removable discontinuities. What's another word for removable discontinuity that we learned on Friday? It's the same thing as a hole in your graph or a removable discontinuity. So if you see those, you're looking for the same thing when you're looking at my rules on my poster. So we're going to have to identify horizontal asymptotes, vertical asymptotes, and any slant asymptotes and holes. So a lot of things you're checking for. That's a review of last week. That's what you're going to start with. Then part B. Let's read part B to figure out what we're doing before we start. Who's going to read it? Who can read? Go, Melanie.
Determine all points on the graph of f of x, such as the y-coordinate is equal to 1. What methods can you use to solve this problem?
Okay, so then you need to talk in your groups and figure out how do I find out where this equation is equal to 1 and what are some strategies I could use to solve that. We're going to discuss those when we come back, okay? 2 parts. I'm putting it on y'all again. Review your rules from last week. List all the things about the rational function. And then part B, solve for where it's equal to 1. Go. So vertical, let's start there. Vertical would where be where what happens. So it should take like 10 seconds versus denominator equal to 0. You talk to what? You talk with him? Who said that?
If there's one more.
Okay, stands for y'all. You have your stamp sheet. Mr. Common Denominator 12, Mr. Common Denominator 6, shoot your stamp sheet. I know I'm telling you how to get the people that have stamps. Are we focused, Eli Lazaro? Eli, what are you talking about? Good. Yep, keep going.
We got some red.
We have some papers. How you doing, guys? So where's vertical asymptote? What's the row for vertical? Get your little blue sheet or the yellow folder.
I already know what a
Zero.
is when
The zeros at the bottom, so look at the bottom. There you go, right down. See, that should be like the first 10 seconds. Boom.
you already know horizontal.
Yeah, why?
Because that's
Bigger on top.
It's the same watch, boy.
Hey, no talk about watches.
Wait.
Slant and oblique. Slant asymptote.
That's the same thing as oblique.
Asymptote.
Where do they happen?
And the exponent at the top is greater than 1.
Is that in this case?
Yeah.
Synthetic division.
Yes,
Just be careful with your synthetic. Yay!
So you put negative.
Keep looking.
So you put negative 1.
Negative 1, but then is there an extra term? And so the remainder doesn't matter. So we just write this as x minus 5 or y equals x minus 5. Still looking, man. Okay, call me over later if you have it. I'd love to give you a stamp.
You will be negative 1.
Okay, so where was our where the denominator is equal to 0, what would make the
No, it's
denominator
negative
0?
4. Yeah.
Okay, x equals -5, boom, done with that one. On to horizontal. Is it bigger on top, bigger on the bottom, or are they the same? Okay, bigger on top means what? Bigger on top. Automatically? Okay, now go on to slant.
You left it at 5 minutes and you didn't want to.
That's what No, it means a couple of things. So like if I have something like this.
Negative 5. Negative 5 to negative 5 is fine.
If both of them are factors, the numerator and the denominator, a common factor is a bigger factor. This is a common factor that would cancel. So x equals -1 is not a vertical chord, it's equal. Okay. This is 9 because x plus 5, there's nothing x plus 5. And then set is the whole thing equation equals 1 to try to solve and figure out where. Okay, I'm gonna give you a few more, like 1, 2 more minutes maybe. Okay, be careful with your synthetic, this is great, but it has x squared, it's 1, but then is there an extra? So you need a little 0 in there. This is wonderful, good. This is true, except we learned on Friday that for the slant asymptote, this is true if I just asked for you to divide, okay? But when I ask for the slant asymptote, it's just the quotient polynomial without the remainder. So it'll just be y equals, you have to write the final answer here. Your slant asymptote is y equals x minus 5. Or, yeah. Or plus 5? Yep. This is good, except now you need to write the equation. So if I asked you to just divide and use synthetic division, you'd say 1x minus 5 plus 24 over x plus 5. but we learned for slant or oblique, we just care about the quotient monomial, not the remainder. So we would say y equals for your poles, remember we looked at cases like this where you factor the top and the bottom? If there's a common factor like that x plus 1, x equals -1 is a pole, not a vertical. So in that case, x equals -1, which would be the 0 of that common factor, is a pole, not a vertical asymptote. So in your case, x plus 5 is on the bottom. Is there any x plus 5 and on the top that you could cancel? No. So there are no poles.
That's only when there's
Common factors on the top and bottom. Right. Factor the numerator and denominator, anywhere that the factor cancels. That's for the yellow.
That's what I have to do right there.
Did y'all get the review from the yellow folder? Okay. So you can use it to look up the rules if you need a reminder. They're all on there, like my poster. Yeah. Okay. 30 more seconds, and we're gonna come back. So 1. Where's your standard? Okay. This should have gone down by a power. It used to be x squared, so this would be 1 x. No, an x. Okay. Oh, so this was a -5 over here.
Alright, so what happened?
This to the root of the opposite y is equal to minus 5.
Why?
And then plus 24 is your remainder.
We don't care about it, bro.
Alright, eyes up here, let's stop. We're going to check through these and talk about B and then go on to solving some other rational equations that get a little more complicated. So first up, horizontal, there were none. Vertical was at x equals -5. That's the zeros at the bottom. Your oblique asymptote or slant asymptote, once you do synthetic division, should have given you the equation y equals x minus 5. That's what we learned on Friday. If you need a recap, then that video is up, or come talk to me tutorials this week and I can go back through slant, oblique, and holes. For your holes, that's like this and right over here. I was explaining to this group. Remember, that's anywhere a common factor cancels, like a case like this. In this one, there's nothing that cancels on the top and bottom when you factor, so you would say there are no holes, okay? So when you graph that, you could start sketching those things. It'd be kind of hard to sketch the whole thing because I'm not going to have y'all find the intercepts and all that for right now. But you could also graph it on your calculator. And using your calculator or using algebra, now in part B, we could find where our graph is equal to 1. So let's pick up there. If I have x squared minus 1 over x plus 5 equal to 1, on your calculator you could find those values by tracing or finding the intersection. But if this is a non-calculator, this is going to be another example of where we're kind of solving involving a rational equation. Okay? So what thoughts do we have? Someone that got started with this, or even if you didn't, if you see now, what could I do to start off with to start solving this? Ihong? Yeah, and what we're kind of doing here is similar to before, where because this is kind of still like a common denominator, it's kind of like we're multiplying times that common denominator on both sides. So this is going to cancel, and we have x squared minus 1 equals x plus 5. Since we have an x squared and an x, we're not going to be able to combine like terms. So we're just going to move everything to one side. Subtract x over subtract the 5 over, if I do -1 minus 5 more, what did y'all end up with? -6, because subtract, -1 minus 5 would be -6 equals 0. Okay? And then something that looks like this, what do we do? Box. We do our box, and you should end up with x minus 3, x plus 2 equals 0. So these are our two solutions of where you should see on your graph that you're equal to 1. Perfect. The only thing you need to watch out for when you're solving with denominators like this, when we multiply on both sides and kind of like make our denominator go away, we have to watch out for the restrictions that could have been on our domain. Look back at your asymptotes and things. What x value, we didn't write our domain, what x value would we throw out, raise your hand, of our domain, looking back at part A. What x value for this function would we throw out of our domain, Jonathan?
X equals -5.
Right, -5, we can't have it, it gives us 0 on the bottom, right? So be careful, there's going to be some examples you're going to see later where one of the answers we get could have been like -5, for example, and kind of almost like an extraneous solution, we would throw out any answers that aren't in our domain. But both of these are good, right? 3 and -2 don't give us any problems, so you can keep them. Cool? Okay, so let's summarize these steps right here for solving rational equations. Then we're going to get to just a few more complicated ones before we get out of here. Okay, so first up, determine any domain restrictions like I just talked about so that when you are solving, you make sure that you don't solve for something that's actually not in our domain. Our key idea kind of from today that we've seen in these problems are when I have my denominator, I've got to in some way multiply both sides by an LCD, stands for my least common denominator. If you would rather multiply times just a common denominator, you don't have to use the least, but the least is nice. And last but not least, once you've multiplied times your least common denominator, you'll either end up with something that looks like this, or something that had x's that we could combine. So in general, you're just going to use a lot of different strategies for solving your resulting equation. Okay? Alright, so let's take a look at, we're not going to get obviously through all of these, but this skill is not going to be assessed a whole lot, so we'll kind of just keep rolling in these skills throughout the year. But you will see 2 of these on your problem set. So let's talk about this first one right here, about kind of similar to the last problem, but we got this extra plus x over here as well, okay? In general, even though we got that plus x over there, we still want to find a common denominator, which in this case, since this is over 1, you can use the x plus 8. You just got to put x plus 8 on the bottom of everything, right? Okay, for this first one, if I need x plus 8 on the bottom, sorry, not x plus 8, x minus 8, then I just need to also have multiply times x minus 8 on the top, right? Picture those would cancel out. That's the same thing as just having x. Isn't this equal to x? Because x minus 8 over x minus 8 is 1, they would cancel. Okay. Plus 6 over x minus 8. Now we've got a nice common denominator, right? Equals, and then if you really want, we could write even 0 over x minus 8 because that's the same thing as 0, right? Common denominator all the way across. Multiply each side by our least common denominator of x minus 8, and what happens to all those x minus 8s? They're going to go away, and we'll just end up with x times x minus 8 plus 6 equals 0. Made all the bottoms go away, multiplying times x minus 8 on both sides. Okay? And then now our last step was to just solve. So I'm going to multiply these, x squared minus 8x plus 6 equals 0. This one's fun because your box is not going to work. And so, I know, tragedy. So, anyone remember that old trick we had for if your box isn't going to work, what can we do? Yep. negative b plus or minus the square root. Yeah. So let's do it. Negative 8 is 8 plus or minus the square root b squared. What's 8 squared, everybody? 64, thanks. Ooh, doing it by myself. Minus 4. A is 1. C is
6.
all over 2 times 1. And if you solve all that, you're going to end up with 2 answers that will be our answers. Not bad. 64 minus 24 gives you 40. It's not that bad. Keep in mind, what was our domain restriction? What was the only value that if we were to get, we would be bad? Well, we give a 0 on the bottom. 6? 8. So if you can 8, don't use it. You gotta throw it out. Okay? Bye-bye. Hey, Kevin. Can you turn that off?
Alright.
That was like the first thing.
Yes, I would have done it.
I want to go to Trump.
Yep.